the Arduino Uno microcontroller. Okay, so here, so the clock pulses will be in the manner of 16 megahertz frequency. So each clock pulses will counted by your timer. Okay, so it will count each clock pulses. So based on the clock pulses, it will increment or decrement. Okay. So based on, so we can use this timer in the increment manner or decrement manner. So basically two types. Okay. So if the timer, it will count from 0 to n, or setting the time by the user. Okay, or set the time I will take. So this method is called ascending method. Okay, so this is the ascending timer. Okay, so this is ascending. So if the counter will start decrementing. Okay, so at what time you are setting, so from that time it will decrement the count. So that is nothing but, so from the set time it will goes to the 0. So this is the decrementing, right, or descending. ಸೊ ಇದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ, ಸ್ಟಾಪ್ ವಾಚ್ ಅಂತ ಕರಿತೀವಿ ಬೇಸಿಕಲಿ. ಓಕೆ, ಸೊ ದಿಸ್ ಕೈಂಡ್ ಆಫ್ ಟೈಮರ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅನ್ ಸ್ಟಾಪ್ ವಾಚ್. ಓಕೆ, ಸೊ ಇನ್ ಮೊಬೈಲ್ phone you can also find the stopwatch operation, right? So when you are starting that stopwatch operation, it will start from 0 to 0 to some level. Okay, so some take n times. Okay, so it will directly goes from 0 to 1 2 3 4 5 like that. Okay, so it will start in the ascending order. So that operation is called as a stopwatch. Okay, so if the timers start from setting time, and it will keep on counting in the descending order, so then it is called as an so basically timer. Okay, so what timer it will do, so it will set the time. So the time is setting by the user. Okay, if the time is set, so it will start decrementing that count basically. So that is called as a timer. And if the timer start from 0 to so it will timer is start from ascending order, so then it will call it as a stopwatch. So basically two types. Okay, so timer basically, so it will decrement the count. Okay, so we'll see how it will do the multitasking. Okay, so just I will give the one requirement now. Okay, so just see, so this is my requirement. So what that requirement is, so I want to turn on. Okay, so listen carefully. Okay, the first point is I need to turn on. Okay, LED. Okay, for every 1 second. Every 1 second. Okay, turn on LED for, or blink LED. Also you can take turn on LED for 1 second and turn it off, for another second. Okay, so ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀರಾ, ಸೊ 1 second LED ಆನ್ ಮಾಡ್ತೀರಾ, 1 second LED ಆಫ್ ಮಾಡ್ತೀರಾ. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ಫಸ್ಟ್ ರಿಕ್ವೈರ್ಮೆಂಟ್. ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಈಸ್ ಟರ್ನ್ ಆನ್ ಬಜರ್. ಓಕೆ, ಫಾರ್ ಎವ್ರಿ 5 seconds. ಸೊ 5 seconds ಟರ್ನ್ ಆನ್ ಮಾಡ್ತೀರಾ, ಸೊ ದೆನ್ 5 seconds ಟರ್ನ್ ಆಫ್ ಮಾಡ್ತೀರಾ. ಟರ್ನ್ ಆಫ್ ಫಾರ್ another 5 seconds. Okay, so this is my requirement. ಯಾವ ಥರ ಮಾಡ್ತೀರಾ, ಸೊ ಎವ್ರಿ 1 ಸೆಕೆಂಡಿಗೆ LED ಟರ್ನ್ ಆನ್ ಆ್ಯಂಡ್ ಟರ್ನ್ ಆಫ್ ಆಗಬೇಕು. ಸೊ ಆ್ಯಂಡ್ ಎವ್ರಿ 5 ಸೆಕೆಂಡಿಗೆ LED ಬಜರ್ ಟರ್ನ್ ಆನ್ ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ಟರ್ನ್ ಆಫ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಯಾವ ಥರ ಬರ್ತೀರಾ, ಯಾರು ಕೋಡ್ ಹೇಳ್ತೀರಾ ನನಗೆ. ಸೊ ಹೌ ಕ್ಯಾನ್ ಮೀಟ್ ದಿಸ್ ರಿಕ್ವೈರ್ಮೆಂಟ್. So just assume you are connecting LED to 13 pin and a buzzer to 12 pin. Okay, we'll go for Tinkercad. Okay, so take Arduino board and breadboard, then LED, then buzzer. So here we have the buzzer. Okay, just connect ground. So negative pin to ground and connect this ground to breadboard. And positive pin of LED should be connected with 13 and buzzer pin. Okay, so this is the simple connection. So ಇವಾಗ ಹೇಳಿ, ಸೊ ಎಲ್ ಇ ಡಿ ಎವ್ರಿ ಸೆಕೆಂಡಿಗೆ ಟರ್ನ್ ಆನ್ ಆ್ಯಂಡ್ ಟರ್ನ್ ಆಫ್ ಮಾಡ್ತೀರಾ. ಸೊ ಎವ್ರಿ 5 ಸೆಕೆಂಡಿಗೆ ಬಜರ್ನ ಟರ್ನ್ ಆನ್ ಆ್ಯಂಡ್ ಟರ್ನ್ ಆಫ್ ಮಾಡ್ತೀರಾ. ಸೊ ಕೋಡ್ ಯಾರು ಹೇಳ್ತೀರಾ? ಶಿಲ್ಪ,
Pin mode,
ಪಿನ್ ಮೋಡ್,
buzzer come out.
buzzer come output. So initialization is done. Then ಇವಾಗ ಹೇಳಿ, in the white loop, you have already written the LED for turning on and turning off for every 1 second.
Yes, sir.
ಸೊ ಜಸ್ಟ್ ಇದನ್ನ ರಿಸಲ್ಟ್ ನೋಡಿ ಆಮೇಲೆ ನನಗೆ ನೆಕ್ಸ್ಟ್ ಹೇಳಿ. ಓಕೆ, ಸೊ ಎವ್ರಿ 1 ಸೆಕೆಂಡಿಗೆ ಎಲ್ ಇ ಡಿ ಆನ್ ಆಗ್ತಿದೆ, ಎವ್ರಿ 1 ಸೆಕೆಂಡಿಗೆ ಎಲ್ ಇ ಡಿ ಆಫ್ ಆಗ್ತಿದೆ, ಕೋಡ್ ಕರೆಕ್ಟ್ ಇದೆ. ಸೊ ಇದ್ರ ಜೊತೆಗೆ ನೀವೇನು ಮಾಡಬೇಕು ಅಂದರೆ 5 ಸೆಕೆಂಡಿಗೆ ಬಜರ್ ಆನ್ ಮಾಡಿ, 5 ಸೆಕೆಂಡ್ ಬಜರ್ ಆಫ್ ಮಾಡಿ. ಏನು ಮಾಡ್ತೀರಾ?
Next, after digital write delay load delay ಆದ್ಮೇಲೆ next digital write
ಓಕೆ, ಡಿಜಿಟಲ್ ರೈಟ್,
buzzer comma
ಬಜರ್ ಕಾಮ,
I
ಓಕೆ, ಹೈ,
delay
ಡಿಲೇ ಎಷ್ಟು ಕೊಡ್ತೀರಾ?
5000 ಅಂದ್ರೆ 5 seconds ಆಗ್ಬೇಕು.
5000. ದೆನ್
Digital write
ಡಿಜಿಟಲ್ ರೈಟ್,
buzzer comma loop.
ರೈಟ್, ಬಜರ್ ಕಾಮ ಲೋ. ಫೈನ್. ಅದಾದಮೇಲೆ
Next delay
ಡಿಲೇ ಫಾರ್ 5 ಸೆಕೆಂಡ್
5 seconds.
ಅಲ್ವಾ?
Yes, sir.
ಸೊ 1 ಸೆಕೆಂಡ್ ಎಲ್ ಇ ಡಿ ಆನ್ ಆಗಿದೆ, ಆಫ್ ಆಗಿದೆ, ಫೈನ್. ಸೊ ಬಜರ್ ಟರ್ನ್ ಆನ್ ಆಯಿತು, 5 ಸೆಕೆಂಡ್ ಆಯಿತು ಆ್ಯಂಡ್ 5 ಸೆಕೆಂಡ್ ಆಫ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, ಫೈನ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ಬಟ್ ಅಗೇನ್ ಎಲ್ ಇ ಡಿ ಆನ್ ಆ್ಯಂಡ್ ಆಫ್ ಆಯಿತು. ಬಟ್ ಇಲ್ಲಿ ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ನಾಟ್ ಮೈ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಅಲ್ವಾ? ಸೊ ಎವ್ರಿ 1 ಸೆಕೆಂಡಿಗೆ ನೀವು ಎಲ್ ಇ ಡಿ ಆನ್ ಆಫ್ ಆಗಬೇಕು ಅಂದರೆ, ಬಜರ್ ಆನ್ ಆಫ್ ಆಗಬೇಕು ಅಂದರೆ ಅಷ್ಟೊತ್ತರೊಳಗೆ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಎಲ್ ಇ ಡಿ 3 ಟೈಮ್ಸ್ ಆನ್ ಆಗಿರುತ್ತೆ, 2 ಟೈಮ್ಸ್ ಆಫ್ ಆಗಿರುತ್ತೆ ಅಲ್ವಾ? ಅವಾಗ ನಿಮಗೆ 5 ಟೈಮ್ಸ್ ಆಗುತ್ತೆ, ಅವಾಗಷ್ಟೇ ಬಜರ್ ಟರ್ನ್ ಆನ್ ಆಗಬೇಕು. ಬಟ್ ಇಲ್ಲಿ ಆ ಥರ ಆಗ್ತಿಲ್ಲ. ಎವ್ರಿ ನಿಮ್ಗೆ ಏನಾಗ್ತಿದೆ ಅಂದರೆ, ಸೊ ಎವ್ರಿ 10 ಸೆಕೆಂಡಿಗೆ ಎಲ್ ಇ ಡಿ ಟರ್ನ್ ಆನ್ ಆಗುತ್ತೆ. ಸೊ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್. ಓಕೆ, ಯು ಕ್ಯಾನ್ ಸಿ ಹಿಯರ್. ಸೊ 1 ಸೆಕೆಂಡ್ ಫ್ರಮ್ 2. ಓಕೆ, 2 ಸೆಕೆಂಡಿಗೆ ನಿಮ್ದು ಎಲ್ ಇ ಡಿ ಆಫ್ ಆಗಿದೆ ಅಂದರೆ, ಸೊ ಇಟ್ ವಿಲ್ ಅಗೇನ್ ಟರ್ನ್ ಆನ್ ಫಾರ್ 12th ಸೆಕೆಂಡ್ ಅಲ್ವಾ? ಸೊ ನೋಡಿ, ಸೊ ಎವ್ರಿ 10 ಸೆಕೆಂಡಿಗೆ ಆಗ್ತಿದೆ. ಸೊ ದಿಸ್ ಈಸ್ ನಾಟ್ ಮೈ ರಿಕ್ವೈರ್ಮೆಂಟ್. ಸೊ ಮತ್ತೆ ಯಾರು ಹೇಳ್ತೀರಾ? So basically we will call it as a multitasking. So before at the same time, so you have to turn on the LED and you can also turn off the buzzer. So because you can see here, so for every 1 second it will turn on and another second it will turn off. So this process will continuously goes on. Okay. So again in the time of buzzer, so it will turn on for 5 seconds and it will turn off for another 5 seconds. Means at the 5 seconds, so the another operation will also carry on the LED also, right? So that means so we are doing the multitasking. Okay. So but here this is the delay method. So first it will turn on the LEDs because of the sequential execution order. So first it will turn on the LED. So it will wait for 1 second. So delay is nothing but what? So your processor is in the idle mode. So it will not do anything. So just it will remaining in the empty loop. Okay. So just it will count for thousands counts. Okay. So then it will wait for 1 second. So then it will go for another operation called making LED low. So this was the second statement in the program. Okay. So again you are using delay. So again your processor in the idle state. Okay. So again it will does not do any other operations. So while in the delay. So again it will go for the buzzer turning on. Okay. So after exactly 2 seconds. Okay. So and it will wait for 5 seconds. So it will turn off the buzzer and again it will wait for the 5 seconds. So this process will goes on continuous. Okay. So this is not a multitasking. So this is a normal programming. Okay. So now if you want to achieve multitasking, so then we can use we can make use the timer concepts. Okay. So here, so either so without timer you can also do the operation, but you won't get an exact result. Okay. So just we can initialize the counter variable. Okay. Every time it will count the numbers. Okay. So based on the counter, so we can do the particular operation. Okay. So this is the small application. So in this case, we won't get any error. Okay, or false result. But in the larger applications, so we get obviously we are getting so false result. Okay, so when you are going for the variable method or counter method, okay, so that are the normal counter method. So that's why so we'll go for the here. So we'll go for the timer concept. So in Arduino, so microcontroller have the so inbuilt timers. Okay. So there are three types of timers are available. Timer types in Arduino. Okay. There are three types. So one is okay. There are basically three types. So one is so timer 1, timer 0, timer 1, timer 2. So these are the three timers. So timer 0 is the 8-bit timer. Okay. So 8-bit timer. And timer 1 is the 16-bit timer. And timer 3 is again it is 8-bit timer. So you are using 8-bit timer, right? So ಏನು indication ಮಾಡುತ್ತೆ 8-bit timer or 16-bit timer ಯಾರಾದರೂ ಹೇಳ್ತೀರಾ? So bit of timer will define the resolution of that timer. So in the same case of the ADC also, right? So in the ADC you can also define the resolution based on the number of bit. Okay. So 10-bit ADC is nothing but what? You are getting the 1023 levels, right? From 0 to 1023. So that will define the resolution. So again in the timer also, so the bit of timer will define the resolution of that particular timer. So here, so how you can define the resolution or range basically, so you can call it as a range. So how you can define the range? So just you have to go for this combination. Okay. So similar to 2 raised to n. So n here it will indicate the number of bits. Okay. So that means so timer 0 will have the resolution called 2 raised to 8. So that is nothing but so we'll have only 256 ranges. Okay. From 256. Okay. So from 0 to 255. So that is the meaning. If you are using timer 0, so it will count only 256 counts or 256 clock pulses. Okay, from 0 to 255. So that is the resolution of your timer 0. So then in the case and similar to the timer 2 also it is an 8-bit. So again it will count so same range. So then we have 16-bit timer. Okay, so 2 raised to 16. So we'll get around 65,536. Okay, so this is the range for 16 bit, or this is the resolution. So from 0 to 65 and 535. So this is the range. So up to this much you can count the clock pulses. So that is the meaning. Okay. So timer 0 and timer 2 will have the 8-bit timer. Okay. So these are the 8-bit timer, and timer 1 is the 16-bit timer. So here in the Arduino, so Arduino will provide some inbuilt function for these timers. Okay. So we already used the delay function. In the delay function also we'll use timer 0. Okay. Here in the delay function they will use timer 0, and then we have some another inbuilt functions called so delay function we already used. Okay. So then we have delay microsecond. Okay. Microseconds. So this is also one of the function, inbuilt function. So then we have millis. Okay. So then we have micros. So some of these are the inbuilt functions. So delay and the delay microseconds, these are used to provide the delay. So remember this point. Okay. So delay and delay microseconds. So these two are used to generate a delay. Okay. So but here milli is nothing but this. So this is the inbuilt function. It will use the milliseconds. Okay. And micro is nothing but it is also an inbuilt function. It will use the time in microseconds. So it will use in time in the milliseconds, and it will use time in the microseconds. So that is the meaning. Okay. So just delay and delay microseconds. So they are used to generate a delay. So here these two inbuilt function will use the current time. Okay, in terms of millisecond and the microseconds. Okay, is that clear? So in the delay function, within the parenthesis we have to provide the numbers. So that numbers will be treated as in terms of millisecond. Okay, so we have to provide milliseconds in the loops. Okay, so in the delay microseconds, so it will treated as this number in terms of microseconds. Okay, microseconds. So it means, so for example, so delay 1000 is nothing but it is equivalent to 1 second, right? So then what about delay microsecond 1000? Okay, delay microseconds 1000. So there is a difference between the delay function also, delay microsecond. Okay. So it will count this 1000 as a millisecond, and it will treat it as 1000 as a microseconds, 1000 microseconds and 1000 milliseconds. So that is the meaning. Okay. So then the milli function, it will provide the current time in milliseconds. Okay, time in milliseconds, in terms of milliseconds. So then in micros it will use the time in microseconds. So these are the difference. So just I will show you here. Time. So just I will remove the buzzer. So this is the LED. So delay means, so you are giving 1000 milliseconds, so exactly it will turn on for 1 second and turn off for another second. So then instead of delay, so just I will use delay microseconds. Okay. here also same thing, delay microseconds. So then run the code. So your loop was not declared in this code. Delay microseconds. So delay microseconds. So you can see here, so it is in the state of turn on, but so internally it will turning on and turning off the LED. So because it will do that operation in the microseconds only, we have given 1000 microseconds. So now I will increase it to 10,000 microseconds. Okay. So this is the difference in the delay function and the and delay microsecond function. Okay. So like that, so we have to increase the numbers in the delay microseconds. So it has the 10 raised to 6. Okay. So like that, so we can use the delay and delay microseconds. So some of the applications or some of the sensor will require this microsecond. So they will require the delay in the microseconds. So in that case, so we can use the delay microseconds. So in case of ultrasonic sensor, okay, so that will require only 10 microseconds for sending the ultrasound waves. So in that kind of application, so we'll use the delay microseconds. Okay, normally we won't use this delay microsecond, so the delay is sufficient. Okay, so but in some applications or some sensors will require the delay in the microsecond. So in that case, so we'll use the delay microseconds. Okay, so this is the use in the code. Okay, so now I will go for the another functions, so called milli and the micro. So let's see, so it will use the correct result or not. Okay, so just I will read that information and I will display on the UART. Okay. So just for that, so I will remove this line. Okay. So in the while loop, so I will initialize a variable called so int, or can take long int. Okay. So just I will take unsigned long for storing the large numbers. Okay. So time in milli. Okay. Millisecond. So just I will initialize milli function. Milli is. So milli is the function. So that will use the time in milliseconds. Okay. And after that, just I will print that information or value on the serial monitor. Serial dot print. Okay. Again I will display time in millisecond. Okay. So then I'll print serial dot print ln time in millisecond. So just okay. Before that, I have to initialize the variable or initialize the serial monitor. So begin 9600. Now run the code. You can see, so it will use the time in millisecond. Okay. Time in the millisecond. Here this is actually slow. Okay, because of the simulation, online simulation. So just I will show you the result in the hardware. Okay. So just I will copy this code. So it will use exactly exact milliseconds. Okay, I can check it. So this is your counts. So 11 second, 12, 13, 14, 15, 16. Okay, right? So it will use the time in milliseconds. So this is the function. Okay, this is inbuilt function. So when the processor will execute this statement, okay, that is nothing but milli is function. So then it will start counting the time in milliseconds. Okay. So now I will use microseconds. Okay. So this is millisecond. Now I will go for microsecond. So just use micro function. Micros. Okay. So in microsecond and upload the code. So you can see, so it will use in the microseconds. Okay. So you can clearly see the difference for millisecond and the microseconds. Okay. So what is the difference here basically? So ಏನು difference ಕಾಣಿಸ್ತಿದೆ ನಿಮಗೆ? So for millisecond and microsecond, so just I will print on the both. Okay. So in the same serial monitor, I will print both times. Okay, times in millisecond and microseconds. Okay. So just I will take another. Time in micro, and this is milli. So just I will use, okay, just I will use print time in microsecond. I'll copy these two lines of code and give the one tab of space. Okay. So time in millisecond and time in microsecond. So then let's see the result. So done uploading. So you can see here. So we have the same result. Okay. So once and long time in microsecond. Okay, you have to change it to micro. Okay. So you can see here. So it gives same result. Okay. You can check it. So this is the first is the time in millisecond and time in microsecond. So basically what the difference? So just milli is nothing but you have the 10 raised to minus 3. Okay, so that's why you will getting 3. Okay, so we are continuously varying 3 digits here. Okay, so in the micro means we have 10 raised to minus 6. Okay, so you can see here, so we have the 6 digits. Okay, so this is micro and this is millisecond. Fine. So this is the inbuilt function. So milli is and microsecond or micros basically. So you can use any one of the inbuilt function, timer functions, and make use in the your main application or operation. So now, so before entering into this requirement. Okay, so turn on LED for 1 second and turn off buzzer for 5 seconds. So just I will turn on the LED so after 15 seconds exactly. Okay, so just I will use the timer. Okay, so we already have the time in milliseconds and microseconds. So just go for the condition. So after 15 seconds, I need to turn on the LED. So after 20 seconds, I need to turn off the LED. Okay, this is my requirement. So, in this case, so you're using inbuilt function time in millisecond. Okay, then I will open my serial monitor so you can check it. So LED is also turned off, okay, at initial state. So and it will also doing the printing timing, okay, time in millisecond and the microsecond. At the meantime, so when it will reaches 15, okay, it will turn on the LED, okay. So and again it will go doing with the similar program or main program. So like printing your main statements or time in millisecond and the time in microseconds, okay. So here, so just in that case, so you are just you are checking the two conditions, right? So if the count is reaches greater than 15 seconds, so it will turn on the LED, fine. So if time is reaches 20 seconds, it will turn off. Okay, exactly fine. So then what about the next 15 seconds? Okay. So if I want to turn on buzzer for, okay, I want to turn on LED for every 15 seconds, okay, I need to turn off LED for every 20 seconds. So for repeating, so this process should be goes on repeating. So in this method, so it will not repeat, okay. So just it will stop at the 20 second. So just I will remove this, okay. So just I will take 5 seconds, okay. So I will turn on LED for 5 seconds. I will turn off the LED for another 5 seconds called 10 seconds. Okay. So then upload the code. So after exactly 5 times it will turn on the LED and 10 seconds it will turn off the LED. So but at the 15 second I need to turn on the LED, right? So but here it will not turn on the LED because so you are given the condition like this. Okay. So if the count is greater than 5 seconds it will turn on the LED. If the count is greater than 10 seconds so it will turn off the LED. So now I need to turn on this LED for every 5 seconds. Okay. ಏನು ಮಾಡ್ತೀರಾ? So unsigned long. So I will take current time. Okay. So just take current time. LED. Okay, we have to so just I will go for LED and buzzer. So current time for LED. Okay, and then similarly I will take unsigned long current time for buzzer. Okay, then I will take an so delay time. Okay, so when you want to turn on the LED or buzzer, so that purpose I will again I will take the time. Okay, so just I will take int. Okay, so LED time. Okay, so I will take, so I need to turn on LED and turn it off LED for 1 second, so that's why I will store 1000, okay, millisecond. So and int buzzer time, so it's 5 time or 5 seconds. Okay, so that is nothing but 5000. Okay, so this is the waiting delay. Okay, so just I will take, this is an previous time LED. Okay, just take previous, so then in the loop case I will take current time. Okay. previous time. Okay, so then go for the loop. So here instead of millisecond, so just I'll go for current time. Okay, current time. Okay, so I will discard this line, second line. Okay, just 2 minutes. So then I will go for the condition now. So just I'll check the condition for current time. Okay, so we have to do repeatedly, right? Current time minus previous time. So here we have previous time 0 at initially. Okay, so previous time here, the current time minus previous time, so greater than or equals to, so that is LED time. So this is the delay time. Okay, every 1 second I need to turn it on. Okay, after another second I need to turn it off. Okay, so that purpose I'm checking this condition. In the current time, so it will measure, so current time in milliseconds. Okay, that will stored in the current time, and you are checking the previous time. Okay, so current time minus previous time, so that will use the exact delay. Okay, so what is the time between the previous time and the current time? Okay, so that purpose we are taking two variables here. Okay, so then that will compared with the delay time. So this is the delay time, and at what time you have to turn it on or turn it off. Okay, so here is at the initial position. Okay, at the initial stage, the current time will have the current milliseconds. Let's say 1 millisecond, and previous time LED is nothing. Okay, that is 0. So 1 minus 0 is nothing but 1 millisecond. So 1 millisecond is greater than equal to 1 LED time. So here we are taken LED time as 1000. So that is nothing but 1 second. We have to wait for 1 second, right? So again, so when it will reach us millisecond is equal to 1000. Okay, so then go for condition. So 1000 minus 0. So that is 1000. So 1000 greater than equal to LED time. So LED time is equal to 1000. So then it will give the true condition. Okay. So the condition is true. So then it will execute this line. So it will turn it on the LED. Okay. So then, so after that, so we have to store that current time into the previous time. So because we have to provide the exact time delay of 1 second. So that's why we have to store the current time into the previous time at the when you are entering into the loop. Okay. So after that, now the current time is stored with the previous time. So the now previous time LED is equal to 1000, and current time is keep on increasing, right? So now say that it will reach us 2000 millisecond. Okay. So 2000. So 2000 minus 1000 is equal to 1000 again. Exactly, we are reaching 1 second delay. So at that time you have to turn it off the LED. Okay. So in the loop you have to do the both the condition here. Okay, for turning on and turning off. Okay. So that's why, so I will write the code like this. Okay. Just I will toggle this LED. Okay. So we are going to do that. So just go for digital read of 13 pin. So that will use the state of that particular pin. If it is high, so then make it as a low. If it is low, then make it as a high. So this is nothing but an XOR operation. Okay. So or you can also simply say that complement operation. Okay. So if it is 0 basically, so it will turn it on, or it will make it as a high. So if it is high, so then it will make it as low. So then we will find out the toggle condition here. Okay. So let's check this for condition first. Okay. For LED. So upload the code. So you can see here it's not turning off because, so here we are not storing previous current time into the previous time. You can observe here. Okay. So it keep on increasing, right? So just assume that in the 1000 we are getting the 1000 delay exactly, but in the 2 second, okay, 2000 millisecond minus 0, so that is 2 milliseconds. So then the greater than LED greater than equal to LED time is not, because so here we have the 1000. Okay. So that's why, so we have to make it as an okay, here we have to store previous time with current time. Okay, previous time is equal to current time. So then we can produce the exact delay of 1 second and upload the code. So you can observe that, so it will give the correct result. Okay. So here in the serial monitor we are not printing anything. Okay. So after, so exactly 1 second it will turn on the LED and another second it will turn off the LED. Okay. This is for the only controlling the LED. So now tell me, so for code for buzzer. So that has to wait for 5 seconds. So already declared here. So buzzer is also declared. Then we have to do the, so just to take another condition for buzzer. So here instead of for LED time, so we have to take buzzer time. Okay. Buzzer and buzzer time. So here also make it as a buzzer. Okay. Buzzer time. So then connect buzzer to the 12th pin. So then it will turn it on. Okay. So here I will print the message. Okay. After every 15 seconds. Okay. So just I will print on message called, so serial dot print ln buzzer on and off. Okay. So instead of LED, just use buzzer. You can see here. So 1 second, 2 second, and third, 4, 5. Okay. So just to wait for 5 seconds. So 1 second. Check it. So buzzer time. So basically it is turned off, right? Okay, fine. So just reset. 1. Okay. So buzzer off. So now onwards we can count the 5 times. Off. Okay. 1, 2, 3, 4, and 5. Now it will print. Okay. So otherwise, so I'll connect, so this LED to 12th pin. Okay, we have 13 pin as an inbuilt LED. Okay, you can see here. So this is inbuilt LED. So that is the 13-bit LED, and this is the second LED. So it will off for 5 seconds and on for 5 seconds, and it will on for 1 second and it will off for another second. You can see here. So these two are working simultaneously. Okay. So this is called multitasking. But if you are using delay, so we cannot do the multitasking. So that's why the timer concept is very important in the measure of the applications. Okay. So this is all about the timer, inbuilt timer functions.